You know, every time you flip a light switch or open a tap or use, well, pretty much anything that comes from a factory, you're plugging into this massive, invisible network of power. It's this world of incredible technology that just keeps our society humming along. And today, we're going to pull back the curtain on it. So, what are these hidden giants really? How do they actually work? And what in the world does it take to control them? We're about to dive into the incredible machines that make our modern lives possible. And believe it or not, our guide for this whole journey is something you'd probably never expect. It's a syllabus. Yeah, an actual course syllabus for an engineering program at Politeknik, Malaysia. We're going to take these academic outlines and turn them into a picture of industrial power that hopefully makes a lot of sense. So according to this syllabus, the whole world of what they call plant technology pretty much boils down to 5 key systems. You've got your steam power plant, the gas turbine, the diesel plant, a compressed air plant, and the super important water pump. Let's start with the OG, the original titan of industry. Steam power. I mean, this is the stuff that kicked off the entire industrial revolution, and it's still a massive cornerstone of how we get our energy today. But how do you actually turn, say, a pile of coal into the electricity that's charging your phone right now? Well, the process is surprisingly elegant. At its heart, it's really just a 4-step dance. Step 1, you burn something. It could be coal, it could be industrial waste, you name it. Step 2, all that crazy heat boils water into super high-pressure steam. 3, that steam gets blasted against a turbine, spinning it at unbelievable speeds. And 4, that spinning turbine is hooked up to a generator, and voila, you've got electricity. Now, here's where it gets really interesting. That second step, boiling the water, engineers have a couple of clever ways to do it. On the left, you see a fire tube boiler. That's where scorching hot gases flow through pipes that are sitting in water. But on the right, you've got a water tube boiler, which flips the whole thing around. Water flows through tubes that are surrounded by fire. It seems like a simple switch, but it has huge implications for pressure and efficiency. And you better believe this kind of brilliant engineering needs constant, careful watch. Technicians are always running these critical safety checks, literally hunting for microscopic traces of oil, the slightest hint of erosion, or even dangerous blisters and bulges on the boiler itself. This isn't just routine stuff. This is about preventing a catastrophic failure and keeping everyone in that plant safe. Okay, so steam is a giant, for sure, but it's not the only game in town, not by a long shot. Now let's check out 3 other pieces of tech that get the job done in some really fascinating, different ways. First up, the gas turbine, and the concept here is just awesome. It's basically a jet engine, seriously. You burn fuel to create this super hot, high-pressure jet of gas, but instead of pushing a plane forward, you use that jet to spin a turbine and make electricity. It's like a jet engine that's been bolted to the ground, incredibly powerful and fast. And this is where things get just ridiculously clever. So imagine all that scorching hot exhaust blasting out of the gas turbine, right? Instead of just letting all that heat go to waste, a combined cycle plant captures it, uses it to boil water, and runs a whole second power plant, a steam plant, basically for free. It's just pure engineering genius and efficiency. All right, next up, we've got an engine we all recognize, the diesel. But here's the wild part. There's no spark plug. The way it works is by compressing air so much, so intensely, that it gets hot enough to ignite diesel fuel all on its own. That explosion pushes a piston, creating motion. That principle, compression ignition, is what makes diesel engines so tough and so reliable. And finally, in this group, we have the compressed air plant. Now, this one is a little different. It's not really about generating power from scratch, but about storing it. You use electricity to run a massive compressor, packing air into a tank at super high pressure. Then, later, you can release that air to power tools or machinery. It's basically a mechanical battery, just waiting to unleash all that stored energy whenever you need it. So, we've covered making power and storing power, but there is one last piece to this puzzle. And you could argue it's the most important and definitely the most overlooked. And that's the simple act of just moving things around. Yep, the humble water pump. I know, it doesn't sound as exciting as a gas turbine, but trust me, from the massive cooling systems inside power plants, to the irrigation that waters our crops, to the pipes bringing water into your home, pumps are the absolute unsung heroes of the industrial world. They're the workhorses that keep everything else running. But here's the thing, you can't just grab any old pump off the shelf. As the syllabus points out, there are tons of different types. So if you've got a specific job to do, how on earth does an engineer pick the right one? Well, they have to think like this. First, what are we moving? Is it clean water, or is it some thick, heavy sludge? Next, how much of it do we need to move per minute? That's your flow rate. Then, how much force or pressure do we need to push it with? And of course, is it efficient, and is it tough enough to survive where it's going to be working? Answering those questions is how you get the job done right. So, from steam to gas to water, we've kind of unpacked the 5 big technologies that really power our world. And each one is its own universe of complexity, right? It takes an incredible amount of skill and knowledge just to design them, operate them, and keep them running safely. And if you want to put all that complexity into perspective, just think about this one number for a second. 80. 80. That's how many hours a student spends learning just the absolute fundamentals of these systems in a single semester. It's a huge testament to the depth and the challenge of this field, and it's a great reminder of the incredible expertise that keeps our lights on. So the next time you flip a switch, maybe you'll think about those powerful, unseen engines that are making it all possible. We have really just scratched the surface today of the tech that built our modern world. And it kind of leaves you with one last big thought, doesn't it? If these are the engines that power our world today, what are the engines that are going to build our future?